We live in a world that is completely built on data. I mean, think about it. Everything from groundbreaking science to the AI that's changing our lives, it's all powered by data. But here's the big question. What happens when that data, the very foundation of it all, is flawed? Okay, let's really get into this.
And the stakes, they're incredibly high. This quote from the Royal Society just hits the nail on the head. In this new age of AI, bad data isn't just about a messy spreadsheet. No, it can lead to some seriously misleading outcomes. We're talking about things like flawed medical diagnoses or climate models that are just plain wrong. It's like we're building these incredible skyscrapers on a foundation of sand. And that really brings us to what you could call data's hidden crisis. We're always celebrating big data, right? The sheer amount of it. But we so often forget the one thing that truly matters. It's quality. And this isn't some small technical detail. It's a huge pillar of research integrity. And honestly, right now, that pillar is a little shaky.
Now that probably sounds like a pretty simple question, but the answer? It's way more complicated than you'd think. Before we can even dream of fixing this problem, we all have to get on the same page about what we're even talking about.
So let's explore that quality question, because it's not as simple as saying, this is good data and that's bad data. The reality is so much more nuanced, and right now researchers are wrestling with some really fundamental questions about how we define it, how we measure it, and even how we talk about it.
Right now, the scientific community is trying to get to the bottom of 5 key questions that really get to the heart of this whole problem. Let's break them down, because figuring these out is the first real step toward a solution.
First up, are we even speaking the same language here? I mean, what a physicist considers high quality might be totally different from what a social scientist needs. We need a shared, common understanding that covers everything from the raw data itself to the metadata, the data about the data, like where it came from and how it was collected.
Second, how do we think about this work? Is making sure data is high quality just another tedious chore for researchers who are already completely overworked? Or is it a vital investment that actually speeds up good, trustworthy science in the long run? That perspective changes everything.
And okay, when we do manage to check the quality, how do we talk about the results? Just saying data is good or pretty good is uselessly vague. We need a standard language, right? Clear labels like passed or compliant so that anybody can look at it and know exactly what they're dealing with.
The fourth question is about the rules themselves, because in a lot of scientific fields, there just isn't a universal playbook for data quality. It's like every lab is making up its own rules, which, as you can imagine, leads to a whole lot of chaos.
And finally, what's the role of all this new technology? Should our tools just be a referee, scoring the data after the fact? Or can we use things like AI and machine learning to be more of a coach, actively helping researchers improve quality from the very start?
So if we look at this model again, you can really see that data quality isn't just one single thing. It's a total balancing act. You could have data that's perfectly consistent, but nobody can access it. Or you could have complete data that can't be verified. Real quality is in that sweet spot where all these different factors come together.
So, with a problem this big and this complicated, who's actually stepping up to fix it? Well, this is where the heroes of our story come in. A brand new global task force of experts put together by CODATA, which is the Committee on Data for Science and Technology.
This group, led by co-chairs Chris Schubert and Camille Zubek, has put forward a plan to establish 3 absolute cornerstones for research data: integrity, provenance, which is basically the verifiable history of the data, its paper trail, and of course, trust. This isn't just some think tank idea, it's a real plan from a major international organization.
And their core mission, their ambition is huge, but it's also crystal clear: to build one single universal framework. The goal here is to create a playbook, a set of recommendations that can be used to manage and assess data quality everywhere, no matter if you're a biologist, an economist, or an AI developer.
Okay, so having a great ambition is one thing, but having a plan to actually get there is another thing entirely. So how are they going to pull this off? Well, the task group has laid out a really clear step-by-step strategy to get from just analyzing the problem to taking real action. Their whole plan is broken down into 6 main milestones. First, they're going to analyze what's already out there, which is smart, right? No need to reinvent the wheel. Then they'll develop new guidance and draft a conceptual framework. After that, and this is the really important part, they're going to pilot it with real-world data to see if it works. From there, they'll get feedback from the entire community,
And finally, they'll use all that information to build a global roadmap to get all the standards on the same page. It's just a really solid, practical approach. So what do we get at the end of the day? Real, tangible results. The group is going to deliver a framework for how we talk about data quality, recommendations for how to embed that quality info right into the data's history, a deep analysis of current standards, and real-world case studies from different fields to prove that it all actually works.
So, let's just tie this all together. Why does any of this, a task force, frameworks, recommendations, why does it actually matter to you? Well, because this is all about building the foundation of trust for our entire data-driven world.
And it's so important to get this distinction. The FAIR principles, making data findable, accessible, interoperable, and reusable, have been a huge leap forward. But just because data is fair doesn't automatically mean it's good data. Think of it like this. FAIR gives you the blueprint and the address to a house. Data quality makes sure the foundation of that house isn't cracked. You absolutely need both.
And this image here shows the ultimate goal perfectly. When we start with good data and use good quality processes, we get good quality results. But it doesn't just stop there. Those results and processes then feed back into the system, improving it, adapting it, and creating this amazing virtuous cycle of better and better science.
At the end of the day, it all boils down to this one simple word: trust. And in this world, trust isn't just a feeling, it's a concrete result. It's what you get when you have data with proven integrity so you know it's accurate, and a traceable provenance so you can see its entire history from start to finish.
Which really leaves us with one last, and I think, critical question. As we build these incredibly powerful AI systems that are going to shape our medicine, our climate policies, our entire society, all of them trained on this data, can we really truly afford not to get this right?